Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. Thanks so much for joining us for another video on the Amazon Web Services Cloud platform. Really quickly, before we get started, I wanted to talk a little bit about StratusGrid. So StratusGrid is an AWS Premier Consulting partner, and we are also an ISV or independent software vendor. We provide a software as a service or SaaS solution called Stratosphere, which is a FinOps and SecOps solution that helps you to optimize your cloud environment and keep track of all of the savings that you've implemented across your entire AWS environment so that you can run an efficient FinOps program. So the topic for today's video is going to be on how to use the AWS Fargate service with Amazon EBS storage to persist data from container-based applications that are running inside of your AWS account. Now, if you're not familiar with Fargate, Fargate is essentially a container as a service platform where you can take a container image and you can simply give it to the Fargate service, and the Fargate service will run that container service for you. And you don't have to set up any infrastructure, right? So you don't have to set up any virtual machines. You don't have to connect them to a cluster manually or anything like that. The Fargate service basically abstracts all of the compute required in order to run your applications. Now, one of the challenges that has been present in the Fargate service for some time has been, how do you persist data outside of an application that's running inside of Fargate? And that's what we're going to be talking about today, specifically around the EBS capabilities. So let's take a look at the announcement here from January 11th in 2024. So it's just over a year old at this point. It's currently February 2025. So it's January 11th, 2024 is when this new feature announcement was made from AWS. And essentially what they're saying here is that AWS Fargate now integrates with the traditional Amazon Elastic Block Storage or EBS service, which allows you to provision and attach EBS volumes to ECS tasks that are running inside of Fargate. Now, the Elastic Container Service has two different launch types. There is the Fargate launch type that has that abstracted compute capability, but if you'd rather set up and manage your own cluster compute capacity, you can actually set up an EC2-based ECS cluster as well, and that's what they're talking about when they say there's two different launch types. There's the Fargate launch type as well as the EC2-based launch type. So they are saying here that you can use EBS volumes in both of those now, but we're really focused in on the Fargate launch type here. I'm a really big fan of Fargate just because when I run a container-based application, I don't want to have to think about spinning up a virtual machine and SSHing into that virtual machine and installing the Docker engine and pulling a container image and all that kind of stuff. I want to be able to just define my parameters, which image I want to use and things like that, and then hand it off to the Fargate service. But one of the limitations that Fargate had for a long time was just the inability to persist data outside of the container unless the application was specifically aware of the storage mechanism. For example, you could always write an application that integrated with S3 object storage or DynamoDB tables, for example. And as long as your application was able to interact with those APIs, then, it was able to write data. But if there was an application, maybe a legacy application that hadn't been updated in a long time, or maybe it's an off-the-shelf application from an external vendor that you're actually running inside of a container, you might not have the ability to tell that application to store data in these different data storage mechanisms. So instead, there was not really a mechanism to persist data outside of the containers for quite a while, but now the EBS service is allowed to work with Fargate now. So this is really great news, and it's pretty seamless. It works pretty well. There are some limitations, though, that you should be aware of. You can only attach a single EBS volume to each Fargate task. So if you need to, have two different storage volumes that have different throughput parameters, for example. Maybe one's a really high throughput for a database process, and maybe another one is kind of lower throughput for more static types of content. You can only attach a single volume, so you won't be able to have that multi-volume capability like you do with EC2 instances. So if you spin up an EC2 instance, you can attach a whole bunch of EBS volumes to it. It's just a virtual machine. You're attaching a bunch of network storage to it. But when it comes to the Fargate integration here, it is limited to just a single one. So we're going to take a look at kind of how to set this up and actually validate that our container did actually persist data onto EBS. What we're going to do is we're going to spin up a Fargate task. We're going to create a really simple program, basically just a PowerShell script that writes some very randomized data to that EBS volume at provisioning time. And then what we're going to do is we're going to tell the ECS service that we want to leave the EBS volume behind. So after the Fargate task terminates, it'll be a very short-lived process that just writes some data and then terminates. But when that task terminates, we want to leave the EBS volume behind. We don't want to delete it. We want to be able to keep it behind so that we can then spin up an EC2 instance. We can attach the EBS volume that was used on the container to the EC2 instance, and then log into that EC2 instance and actually manually validate that the data resides on the target EBS volume. So we're going to take a look at how to do that. I did want to point you to some supporting documentation for all of this, though. So if we take a look at the Amazon Elastic Container Service documentation here, under task definitions, there is storage options for tasks. You can see that EBS is supported for the Fargate launch type here. You also do have the option to use EFS as well. That's been out there for a little bit longer. So EFS is kind of network attached storage, and you could use that from Fargate as well. But now EBS provides just raw block storage to the task rather than using a network file system protocol instead. So there's that document. And then also, if we go a little bit lower here, there is under architect your application, storage options for tasks, and then go to Amazon EBS. This document talks a little bit about the supported configurations here, some of the considerations or limitations that are available in this integration here. So one of the new things that we're going to take a look at that's required here is something called an infrastructure IAM role. Now, if you're familiar with ECS and launching Fargate tasks in the past, you're probably familiar that there's a couple of different identity and access management roles. There is the task execution role, and then there's also the task role. And even though the names are overlapping a little bit, there is a very distinct difference between them. The task execution role is what is used to have permission to do things like download container images from a private ECR container registry instance, right? And so the task role is what your application that's actually running inside of the container itself, that defines what AWS services and APIs your actual application code has access to. So the task execution role is kind of that lower level role that's used to pull a container image from a private repository. And then you've got the task role that's for your application code. But then we have this new role that is lower level called the infrastructure IAM role. So now there's 3 different roles that we have to think about when we're dealing with ECS. And this infrastructure role is what allows the Fargate service to essentially create and then attach the EBS volume to the task that it spins up in the Fargate service. So you do need to pre-create that IAM role, and there is actually a managed IAM policy that has all of the permissions predefined inside of it. So you can just use this existing policy that is mentioned right here, but you will need to create that role, and you can click on this link here, which will take you to this document here under the security section in ECS, and this talks about IAM roles that are used for ECS. So here it talks about the task execution role, talks about the task role, and then it also talks about this new infrastructure IAM role. And there are a couple of other more ancillary ones, but those are really the primary ones that most people are going to be working with. All right, so now that we've taken a look at some of this documentation here, let's go ahead and actually set up a example inside of an AWS account. So I am over here in the AWS Management Console, and if you go to the ECS service here, you should already have a cluster. And when you're dealing with Fargate, when you create a cluster, you're not actually provisioning any compute resources, right? It's not like you're provisioning a whole bunch of virtual machines and creating some kind of complex large cluster. A cluster is basically just a logical resource inside of AWS that allows you to deploy containers, also known as tasks, inside of that cluster. Now, a task is an abstraction on top of an individual container. So a task actually allows you to define more than one container. And when you deploy that task, you basically define how many compute resources in terms of virtual CPUs and virtual memory that you want to allocate to that task. But a task is an ECS concept that actually is kind of a parent concept to the individual containers. So you could have potentially a task that has one container that's running a Postgres SQL service, and you could have a second task that actually has your application running inside of it as an example. Now, generally speaking, it's not good to have that tight coupling between your application and its underlying data store. Generally, we want to kind of keep those concepts separate, but I do want to just kind of mention for the sake of discussion that that is kind of how things are structured as far as the AWS object model goes. So in any case, you want to just have a cluster here. So if you hit create cluster, you can just give it a name like StratusGrid 01, for example, and you want to make sure that it's supported with the Fargate launch type right here. So I've already got one right here. Again, it doesn't actually have any compute resources. All of that is abstracted by Fargate. And if I go to my cluster configuration, update cluster here, you can see that I have the Fargate Spot capacity provider. So that gets me a discount on my Fargate spend using Spot capacity in AWS. I'd encourage you to read up on Spot capacity if you're not familiar with it. It allows you to get a really deep discount, especially good for development workloads or things that don't really need to be 100% reliable or close to 100% reliable, I should say. But you can also use just the standard Fargate pricing model if you'd like to, but since I'm working in a dev account here, I'm just going to use Fargate Spot. Okay, so the first thing I'm going to do is actually go over to the IAM service because I want to show you how to pre-create this special IAM role that needs permission, that basically has permission to create EBS volumes in the EC2 service and attach them to Fargate tasks. So what we're going to do is go to the IAM console here. You can go to the unified search bar here and go to IAM and then go down to roles. And then click on Create Role. For the use case down here, we're going to choose the Elastic Container Service. So you can just search for container or part of that and choose ECS right there. And then we're going to hit Next down here. And we're just going to go ahead and finish this. And we'll call this Trevor-YouTube-ECS infrastructure EBS role. And then I'll go ahead and assign a custom tag here just so my teammates know that I created this resource here. And then once that role has been created, we need to assign the managed policy to it that has all the predefined permissions set up to use EBS with Fargate. So what we're going to do is go to add permissions and say attach policies. And then we're going to reference that infrastructure role. So I'm going to search for infrastructure here. And as you can see, the ECS infrastructure role policy for volumes specifically, that's the one you're going to want there. This is the one that has all of the necessary permissions predefined. So you can see it's got permissions to things like EBS snapshots, because you can instantiate a new EBS volume from an existing snapshot. Maybe you've got some test data that you want to run consistent tests against or something like that. So you can have a snapshot and then just create a volume from that existing snapshot. It needs permission to manage tags on EBS volumes, so it can tag them. It needs permission to attach and then detach volumes and things of that nature. And it also needs permission to terminate the volume after the task has exited. So those are the permissions that it really needs: is create, and then describe, and then attach and detach, and then delete volumes, and all the corresponding managed tagging capabilities as well. So we're just going to go ahead and add that policy to our role. And so now we've got that policy attached right here. And this one also came pre-attached with the role template that we used, but we probably don't need that one. So I'm going to leave it in place for now, but we could probably remove that because this has a bunch of load balancing related permissions that we probably don't really need. But I'm just going to leave that for now. So now that we've created that IAM role, the next thing we want to do is go over to the ECS service. So I'm going to search for container up here, go to ECS, and we are going to create what's called a task definition. Now, if you've ever worked with ECS, you're probably familiar with task definitions because they are a mandatory resource in order to use the ECS service. But essentially what it is If we take a look at an existing one right here, let me take a look at the raw JSON for it here. This is what defines how much CPU, how much memory. It defines things like container entry points. It defines things like what the container image is that we're launching from. It defines things like volumes, mount points, logging configurations, and all that kind of stuff that you typically see with containers. And as I mentioned, container definitions, this property here that's at the root of the task definition, is a JSON array. And in my case here, I only have a single container object defined inside of container definitions, but it is an array, meaning that you can have multiple containers running inside of the same task in the Fargate service. So what you can see here, and I am going to kind of walk you through this in a little bit more depth, but basically I'm just using a PowerShell container image. It's got PowerShell pre-installed. It's kind of like using a Python or a Node.js base image where you can just inject your application code. But then the special thing that we're doing here is we're defining an entry point. And what you can do with PowerShell is you can specify this parameter called encoded command. And what you can do is pass in a base 64 encoded script as a single string. And so that could represent a multi-line script file, but it basically just base 64 encodes it into a single string. And so we just pass that entire script into the container. And what that does is it saves me the extra step of having to build a custom container image and inject a script file. So I can literally just use the base PowerShell image there and then just call a complex script by passing it in as a argument rather than having to actually package up my own custom container image. And that would add a lot more complexity if I had to build a custom container image and then push it up to Elastic Container Registry and all that kind of stuff. So we're just kind of skipping over that, and we're just using a base image that's publicly available out there from Microsoft's Container Registry here. And other runtimes might have similar capabilities, but I write a lot of PowerShell, and so this is just the capability that I used to provide an example here. But essentially, all we're really wanting to do is to write some random data somewhere on the EBS file system. So I actually have Docker Desktop installed locally. And if you're not familiar with Docker Desktop, it's a really cool application. It's supported on Linux, Mac, and Windows, but essentially it just allows you to spin up containers on your system really quickly. On the Windows 11 platform, it uses the Windows subsystem for Linux, or WSL for short. And so I can just run native Linux applications on my system here and kind of prototype what I'm trying to accomplish inside of a cloud-based container before I actually run it. So I can pull mcr.microsoft.com/PowerShell here. I should already have it downloaded. And then what I can do is I can say docker run --rm. That'll clean up the container when I'm done using it. -it. And if I just do that, it's going to give me an interactive PowerShell shell. And so I could run commands like, get child item, for example, which is similar to ls. I could do things like makedir/data, for example, and then do GCI for get child item again. You can see I've got a data directory there now in the root of my container file system. So I can just use this to kind of prototype things really quickly. But what I want to do is basically just generate some really simple random data. So by convention, I generally use /data inside of containers just as a place to store some random data. If I'm testing something out, or if I'm storing some application files, I might just stick them in /data. So typically what I do is I start out by doing makedir/data. And that produces what's called a non-terminating error. So if that directory already exists, it's not going to cause the script to terminate. So we can include that command just to make absolutely sure that that directory exists, even if we've mounted an EBS volume to it. So we're going to include that command in our script. But then the other thing I'm going to do here is just say 1 to 10, which will give me a range. And then what I'll do is say for each of those numbers, and this is % is shorthand for each in PowerShell. What I want to do is say for each of those items, set content, and this will create a file. And then the path of that file is going to be /data/ and then whatever item we pass in. So there's a special variable in PowerShell called $ps_item, and then we'll just add on a .txt file extension after that. And then the value, or the text that we want to write into the file, we're just going to write some random data using this built-in command in PowerShell called new GUID. And then new GUID has a GUID property on it. And if we reference the new GUID the GUID property on the new GUID resulting object there, we get just this raw string, which is the GUID. So that allows us to just generate some kind of random data. And if we actually run this command right up here, which I think we just did actually. So if we do get child item dash path on the /data directory right here, you can see that we have files named 1 through 10 because that is the range operator that we used right here. And then PS item is just substituting each number sequentially from that range and iterating over it thanks to the for each loop here. And so we created 10 different text files. And if I just cat the result, let's do get content. That's the PowerShell command to do that. And we'll say get content dash path /data /5.txt. And as you can see, it's got a GUID inside of that file. If we change it to number 6.txt, it's got a different GUID there. So this is just a really simple way to generate some random data somewhere on the file system. Now, like we talked about, we can take this script that we've created, even though it's a very simple script. What we're going to do is do mkdir /data, put a semicolon, new line, and then we'll run that command. So what we're going to do is take this simple script right here, and we're going to base64 encode it. And to do that, there is a handy website called base64 encode. And if you go to base64encode.org, you can encode a string of text like this little script that we created right here using UTF-16 little endian encoding. So make sure that this is UTF-16 LE, otherwise PowerShell will not be able to interpret it correctly. And click on encode. And this string right here is our script that has been encoded as base64. So now we can use the PowerShell base64 encoded command parameter to specify this script, and it'll just run that script, and we don't have to build a custom container image. So I'm going to exit out of this container and then launch a brand new one here. And if I do GCI, you can see there is no data directory in a fresh container, right? So now I'm going to simulate what we're going to do in Fargate by doing posh-encoded command and then simply paste in that base64 string. So we're launching a child process, PowerShell, and we're passing in this base64 encoded string. PowerShell, this new PowerShell process, child process from the existing PowerShell process that we're currently running, is going to decode that base64 string. It's going to turn it into the PowerShell script that it actually is, and then it's going to execute it. So now that we've run that command, if I do get child item, you can see that that data directory now exists. And if I do get child item on the /data path, you can see that all those files now exist inside of there. All right, so now we've basically validated the commands that we're going to be running. So now what we can do is take this PowerShell script that we're going to run and create a task definition from it. So let's switch back over to the AWS Management Console right here, and let's go ahead and create a brand new task definition. So we'll show how to create this from scratch. And I'm going to call this Trevor, EBS, Fargate, YouTube, test. We're going to use the Fargate launch type right here. We can choose how many resources we want when we launch a task from this task definition. So I am going to choose, let's just use the default of 1 virtual CPU and 2 GB of memory. That's way more than enough. We could also probably bump it down to half of a virtual CPU and 1 GB of memory. So let's actually do that just to optimize it a little bit. And then for the task role down here, we don't need a task role because our application doesn't need to talk to any AWS APIs. We'll just use the built-in task execution role there. We shouldn't actually need that in general, as far as I know, but that is generally what's used to pull container images from private ECR repositories. But the important bit is down here, defining the actual container. So you give every container a name, and this doesn't really mean anything. You could call it container 01, container 02, container 03, and so on and so forth. I'm just going to call this PWSH because it's a PowerShell container. And then the image that we're going to use is actually not from Docker Hub. It's actually from Microsoft's container registry. So I'm going to do mcr.microsoft.com/PowerShell. And then down here, we don't need any port mappings because we're not actually serving a service. We're not creating a network listener. We're just writing some data to the file system and then terminating the container. So we can remove that port mapping there. We can also scroll down here and go down to Docker configuration. And this is where we can define the entry point to our container. So rather than just having PowerShell run as an interactive shell, that's the default behavior that we just saw when we ran a container. We get that interactive shell. We actually want to run PowerShell, comma, dash encoded command, comma, and then we're going to paste in the base64 encoded script that we got by encoding it on the base64encode.org website. So now we have this entry point overriding the default entry point of the PowerShell container image that is going to run that script. Now, the other thing that we need to do is to define the mount points for storage. So if we take a look at storage down here, we can add a volume definition. And so when we define a volume definition, we're not actually creating an EBS volume. The EBS volume itself actually gets created when you run a task from the task definition. Right now, we're just creating the task definition. And so we're just going to call this data volume. And we're going to say configure at task definition creation. That's the default. That does not support EBS though, so we actually have to say configure at deployment. And like it says right here, you can configure one EBS volume when you create or update a service or when you run a standalone task. Now, the other thing that we need to do here, if we try to create this right now, we're going to get an error. So let me add my owner tag as a standard thing there. If we try to create this task definition, we're going to get an error. And it says volumes, data volume, are not referenced by any of the containers. So if we go down here and say add mount point, what we can do is say this data volume that we're declaring, this data volume that we're going to provision in the future when we actually run a task, when we deploy that task, we want to mount that to the PowerShell container, right? Because we could have multiple containers in the task, but I only have one here, so I'm going to choose the one container. We're going to choose the source volume, which is this volume that we're going to create at some point in the future called data volume. And then where do we want to mount that volume that we're creating in the future inside of the container? Well, typically I put it under /data. So I'm just going to specify /data as the mount point for that volume. And so now that we've actually referenced the volume that we are declaring right here inside of the container, we can now create the task definition. All right, so now that we've got the task definition created, we can go ahead and try to launch it on our cluster. So the other thing that you're going to want to have in place ahead of time that I didn't mention earlier is a VPC. And I already do have a VPC with public subnets set up. So you can see I've got this VPC right here called Trevor VPC. If I go down to subnets and sort by VPC, you can see I've got a whole bunch of different subnets here. I have several different public subnets here. I have some private ones too, but I don't have a NAT gateway. So right now I'm just going to do everything inside of the public subnet here because that'll have access out to the internet to pull the container image from the Microsoft Container Registry that we specified in the task definition. Now, the other thing you're going to want to pay attention to is the availability zone that you're launching inside of. Not all availability zones are going to support all types of storage. So when we actually try to run the task, if I try to deploy to US West 2A, which has a certain mapping inside of my AWS account here, it actually has an AZ ID that I would probably have to look up separately here. It doesn't look like I can look at that on the VPC level here. Actually, it's right here. Sorry, I just saw that. So it's actually called US West 2 AZ number 2. So if you're trying to deploy to AZ number 2 in US West 2 region, they do not support the GP3 storage, GP3 SSD storage inside of that availability zone. So if I try to provision a GP3 EBS volume when I deploy a task using the task definition that I created, then we're going to get an error because that availability zone simply doesn't support it. So the other option is to deploy to a different availability zone, or we could just change it to GP2 or we could use a different type of storage depending on what's available in that availability zone. The other reason that the availability zone is important is because when we launch an EC2 instance, after we run the task that populates some data onto a brand new EBS volume, we need that EC2 instance to be in the same availability zone so that we can attach the EBS volume in that same availability zone to the EC2 instance so that we can log into it and actually validate the data that is on the volume. So that's why you want to pay attention to which availability zone you are actually launching a task inside of here. So in any case, I've got the VPC with public subnets. The internet gateway is already attached. My route table is set up to send traffic to the internet gateway that's attached. And so all that stuff's set up. So when we go back to the ECS service, let's go ahead and search for the container service here. We're going to go into our cluster here, and we're going to say, I want to create a task. So I'm going to go to tasks, not services. Services is if you want like a long-running process that you want to be self-healing. So if you have a container that, aborts abnormally for some reason, the service controller will automatically spin it back up. But in this case, I just want to run a one-off task. So I'm going to go to the Tasks tab here and say Run New Task. We're going to choose the default launch type, which is going to be Fargate Spot capacity provider here. The family of task definition, that's just what they call it, task definition family, task definition name. We're going to choose the YouTube one that I created right here. And we only have one revision of it, so we're going to choose that one revision. And for networking here, I'm going to choose my VPC. I'm going to say clear all the subnets because I don't want it to deploy just into any availability zone. I want to be very specific about which availability zone I'm deploying into. So I'm going to go ahead and choose US West 2A, which as we saw was mapped to US West 2 AZ number 2 in my account, but the mapping may be different for your account. I don't need to worry about the security groups because we don't have any inbound service access that we need. We're not creating a network listener with like a web server or anything like that. We do need a public IP because we are going to be downloading from the internet, the container image and all that. Now, the volume section here is really the important part. So under volume, the default is going to be GP3 storage here. And I can say, all right, I want the smallest size volume, which is 1 gigabyte. You can't create any EBS volumes smaller than 1 gigabyte there. You can also specify if you want to provision extra IOPS. I'm just going to leave it at the default there. Same thing for the throughput. I'm just going to leave it at the default minimum of 125 megs per second. You can choose a snapshot that you want to create the volume from if you want to pre-populate some data onto the volume. And so that might be, database files. It could be, static content. There's a whole bunch of different things that you could do. But if you want to kind of pre-prepare an EBS snapshot that you load into a container, you could create one from an EC2 instance and then, capture a snapshot of that if you want to. But what we're going to do is just create a brand new EBS volume. And as you may know, EBS is just block storage, and by default, it does not have a file system on it. So one of the things that Fargate has to do when it creates the volume is it has to create a file system on top of the block storage device. So that's why we get to choose the file system type here. I'm just going to choose ext4. That's one of the most popular file systems for Linux workloads. And then we also have the option to choose our infrastructure role here. So I'm going to choose my Trevor YouTube ECS infrastructure EBS role that we created earlier. And again, that is the role that's going to allow the Fargate backend service to actually create the volume and then attach it to my task. I also like to propagate the tags. So I can propagate tags from the task definition that I already added, which is the owner tag. And I can just propagate that down to the EBS volume. So when the Fargate service creates the EBS volume for me, it'll basically just take the tags that are defined on the task definition and simply add those existing ones to the EBS volume. And then I also like to do the same thing on the task itself. So I like to propagate the tags from the task definition onto the task that we are instantiating. So I think that's pretty much everything that I need to do here. Specify the subnet availability zone that we're launching into, specify our volume configuration right here, and then we can just go ahead and hit the create button, which I know I'm hiding with my head here. And now you can see that it is provisioning that task. Now, there's one other thing that I totally forgot to do, which is to uncheck the default terminate EBS volume on task termination. So this is going to most likely run successfully, but the problem is that the volume that it just provisioned right here in the volumes tab on the task details, this is going to get cleaned up automatically after the task exits. And we don't want that to happen because we want to be able to mount that EBS volume to an EC2 instance so that we can validate the data on that EBS volume to basically confirm that our application did in fact run correctly inside of the Fargate service. So we'll give that a second to run. It really should not take that long. As you can see, it's already gone into the stopped state because it basically just ran that script very, very quickly. It wrote the data to the volume, and now it is deprovisioning it. And as you can see, it already deleted that EBS volume. So that's one of the things I always forget to do is I forget to uncheck the default box that says to terminate the EBS volume when you launch the task. So we're going to go back to tasks once again, say run new task. And hopefully I don't forget any of the parameters this time. So we're going to choose my Trevor Fargate YouTube test task definition. I only have the one revision. For networking, we're going to choose my custom VPC. We're going to clear the selection of subnets, and we're going to choose the US West 2A public subnet. Don't need to worry about security groups. I do need a public IP, so I'll leave that. I'm going to make sure I uncheck this down here. Termination policy, delete on termination. That is checked by default. We want to uncheck that in this case because we want to be able to validate the data after the task exits. So I'll choose 1 GB size. I'm going to choose a file system type of ext4. Infrastructure role, we'll go ahead and choose our infrastructure role that we created. For the tags, I'm going to propagate them from the task definition at the EBS volume level and at the task level. And I think that is everything. So uncheck the termination policy. Everything else should be totally fine there. So we'll go ahead and hit create here. And it looks like GP3 did actually work that time. Maybe when I was testing before, I had chosen a different availability zone. I don't quite remember exactly what happened that time, but I definitely did get an error where GP3 was not available in a certain availability zone that I was trying to provision into, but it looks like it is available here this time. So as you can see, it created the EBS volume. You can see it spun up the task. It attached the volume to the task. And then after the task exits this time, it'll detach the volume from the task because the task is no longer running, but it's actually going to leave the task in place so that we can then use it. Okay, so now we get task is stopping because our PowerShell container ran and it exited. We can even go to the logs right here. You can actually see that we get this error here saying that the /data directory already exists. But of course, that should not terminate the script early. It should just continue running. And we kind of expected that to happen because we mounted the EBS volume to the /data directory in the container. So I kind of knew that it would already exist, but just in case it didn't exist for some reason, I did want to go ahead and create it. So we'll refresh here. And as you can see, it says attachment status is deleted on our EBS volume. However, that volume should still exist in our account. It has an ID of 019. So I'm going to go ahead and go to the EC2 service here. So I'm going to middle click that and open it up in a new tab right here. Go down to volumes. And as you can see, I do have this 1 GB volume right here with ID 019D. So 019D, 1AAE. So yeah, that definitely is it. And it still exists inside of my account. So it's a little bit of a confusing or deceiving status right here. It says deleted, but it's really just the attachment that was deleted. It's not the actual volume that was deleted itself because it was retained after the Fargate task exited. So now that we've got this volume right here, I'm going to go ahead and delete this other one because I don't want to accidentally confuse them. That was one I created from testing earlier. So now we just have the 1 single gigabyte one here. So now what we want to do is go ahead and launch an EC2 instance. And then once that EC2 instance is up and running, then we can attach the volume to that EC2 instance and mount the volume to a mount point inside the EC2 instance's file system, and then we should be able to explore the data that our Fargate task that ran PowerShell created on that new EBS volume. So let's go to launch instances here. I'm just going to call this Trevor01-YouTube Fargate EBS, so I remember what it's for. And then for the image, the operating system image, I'm going to use Ubuntu here. For the instance type, I'm just going to choose a T3.micro. That should be totally fine right there. I'm going to go ahead and choose an SSH key pair here so I can SSH into it. For my VPC configuration, I'm going to choose my custom VPC. And remember, we want to make sure that we're deploying into the same availability zone. So I am going to choose the US West 2A availability zone because that's the same one where we provisioned the Fargate task and the EBS volume for it. I am going to choose a security group so that I can SSH into that instance. I'm going to choose a couple there because I believe those already have pre-configured rules for inbound SSH on them. You may need to configure an inbound SSH rule if you are creating a new VPC and new security groups, so just keep that in mind, but I already have those inbound rules set there. I'm going to go ahead and just bump up the storage a little bit there. Not really any reason to do that, but sometimes I just need a little extra storage. Now, I am going to go down to advanced details and then go down to spot instances here. I'm going to use spot instances for my Fargate task like earlier, and I'm also going to use spot instances for my EC2 instance here because this is a non-production workload. So if it gets interrupted, we'll stop it, and we're going to make it a persistent request. And then I can go ahead and just launch my EC2 instance here. Now that the EC2 instance is being launched in the same availability zone as the EBS volume, so US West 2A is the EC2 instance availability zone, and then again on the left, if I go to Elastic Block Store Volumes, you can see that my EBS volume here is also in US West 2A, and you can see my EBS volume is in the available state, which means that it's not attached to anything else. So the ECS service created the volume for me, it attached it to my Fargate task, the Fargate task ran to completion, which only took a second, and then it terminated, and then the ECS service just left that volume in place. It detached it from the task, but it left it in place, so it's just sitting in the available state. But what we're going to do is actually attach that to our EC2 instance that we just spun up after I get logged into it. So let's go to our EC2 instance. I'll grab its IPv6 address here, or you can use its public IPv4 address if you so choose. And I'm going to go ahead and SSH into it. So we'll go ahead and SSH in. And if I do lsblk, you can see that I've got my root drive right here with several different partitions here. But now what we're going to do is attach the EBS volume that we created from Fargate, and we're going to see that appear in the output from block storage devices. So back under EBS volumes, I'm going to find that volume, 1 gigabyte. We're going to right click on it and say attach volume. And I'm going to choose my EC2 instance. Now, if you don't see your EC2 instance here, it's probably because it's in a different availability zone. So make sure, again, that your EC2 instance that you spin up to do the validation is in the same availability zone as your EBS volume that you spun up from Fargate. Now, I'm going to go ahead and tell it to mount to /dev/SDG and say attach volume. And so now this 1 gigabyte volume has changed from available to in use because it's been attached to a workload. So now if we come back to our SSH session here, if I do lsblk again, you can now see that I've got this second block storage device attached to this Linux server called NVMe1N1. So now the only thing that we need to do, now that we can see that we have this 1 gigabyte disk attached to our EC2 instance, and of course the 10 gigabyte operating system root disk, we can go ahead and just mount this disk to a location on the file system. So typically we do that under the /mount location on Linux. So I'm going to say sudo make dir /mount /some data. You can call it whatever you want to. And then we're going to say sudo mount /dev/NVMe1 n1 to/mount/some data. All right, so now when we go to /mount/some data, that's going to contain the contents of that EBS volume that we created through Fargate. So if we do ls/mount/some data, check it out. Those are the files that we created. And if I want to explore it with PowerShell, it's actually really easy to install PowerShell, at least on x86. They don't have a snap package for it on ARM, unfortunately, but you can do sudo snap install PowerShell and get PowerShell on your Linux server, --classic. Let's go ahead and add that parameter as well. So we can use PowerShell to basically explore the file system as well. And so we'll launch PowerShell. And we'll just say get child item -path /mount/some data. And there it is, right? We've got these 37-byte files that have GUIDs as their contents. So we could say get content -path /mount/some data and just grab any one of those files. So like 7.txt, there's a GUID that was generated by the Fargate task. Grab number 9.txt, there it is, a different GUID, right? So this is just validating that the Fargate task that we created with a PowerShell script that created an EBS volume for us as part of that task creation process is in fact persisting the data to an EBS volume. And remember that we had to uncheck the checkbox that said to terminate the EBS volume when the task exits. We don't want to do that because we want to be able to reattach it to another EC2 instance and then be able to explore that data interactively, which is what we're doing right now. So that's pretty much everything that I wanted to show you. Make sure that you understand how to create that infrastructure IAM role so that the ECS service has permission to create and attach and detach and delete EBS volumes on your behalf inside of your AWS account. And then also make sure that you use that checkbox to allow the EBS volume that's created to be retained. And then if you want to, you can launch an EC2 instance just like we did here. You can follow along. And then you can attach the EBS volume that was created as part of your Fargate task to that EC2 instance. You can mount the block storage device onto the local file system somewhere, and then you can start exploring that data. So feel free to use that technique to launch other types of workloads. I realize that this was a very contrived example. Typically, you're using containers to run long-running services like database servers or web servers or web APIs and that kind of thing. But I just wanted to show you a really simple PowerShell script that just executes very quickly, writes some random data to the EBS volume, and then go explore it interactively. So feel free to check that out. And of course, I am going to ensure that I clean up my spot request here. So this is my spot persistent request that I created. I'll cancel that. That'll clean up my EC2 instance here. And then I'll go to volumes here. And then my 1 GB volume should be detached from that EC2 instance once it's shut down. And I'll go ahead and just delete that volume as well to make sure that that's cleaned up. So we'll give it a second to detach. And if it doesn't, you can always force a detach as well. So I can just right click and say detach and then detach it. And then it should switch to the available state. And after it's in the available state, we can go ahead and actually just delete the volume. But I'll do that after the recording ends here. So just make sure you do that for cost optimization reasons. You don't really have any need to keep these resources around as longer lived resources. So don't make sure that you're not spending extra on your AWS account. In any case, I hope you learned something new from this video. Thank you again so much for watching. Again, my name is Trevor Sullivan, a solutions architect with StratusGrid. And I also just realized that this week that I'm a AWS ambassador as well. So if you go out to the AWS ambassador website, you can find me out there. Let's actually just do a really quick search for that so you can see it. That's actually the wrong site. It's a public site over here. So if you search for the AWS ambassador program and you search for all ambassadors, you can see there's a number of different ambassadors there around the world. And then if you search for StratusGrid in particular, and I had a filter there for North America, but we actually do have 3 different ambassadors. So myself, Ivan Casco, as well as Matt Barlow. So if you're interested in chatting with us or have any questions, feel free to reach out to us. You can also leave a comment down below. Please leave a like on the video and subscribe to our YouTube channel, and check out all of our historical videos on AWS as well. And let us know what you thought, and let us know what other kind of topics you're interested in seeing video content on. Thanks again for watching, and we'll see you in the next video. Take care.